There we go. So, right now, I can't tell if these are similar or not, because it doesn't quite match the definition, because the definition says each angle in one has to match another angle in the other. So I know that that one is 90 and that one is 90, so that's check, check. But the trick is, I gotta make sure the other angles in the other triangle match up too. Does that make sense? So, oh, Kelly, go ahead, what's on your mind?
Nothing.
No, please.
Probably blank right now.
Oh, okay, it's just your expression, I'm like an amphibian, I see motion. And your face
Alright,
changed.
so you said if triangles are similar,
If each angle in one,
each angle in one equals an angle. Okay, never mind.
it's good. Okay, I just want to make sure that, sometimes I screw up when I'm writing things. I want to make sure
I had to
that,
read it twice too.
it's okay.
Yeah.
So here's what it means pictorially. This angle in this one equals this angle in the other one. Check. This one here would therefore have to equal this one here. Now, is it okay if I put those little markers to make sure they're equal? Is that fair to just, that's the pretty standard congruent marker in geometry, if you use little arcs through them. And it's a real quick and easy way to make sure they match up. Please, please.
So do all the angles have to match?
Hold that thought, please. Hold that thought, please. Great question. Great question. Wait. Brittany? Carrie. Brittany's over here. Where's Whitney? Whitney, Brittany. Okay. We're slowly getting there. As I was putting your quizzes in piles, I'm like, I can't picture that person. It's driving me nuts. So, now, this one equals that one. This one equals that one. How about this one? Tell me why this one has to now equal this one. I'm calling on some old geometry knowledge that you may have forgotten from back in the day. Maybe. Possible. Randall?
Well, there has to be 180 degrees in a triangle.
Hold that thought right there. Every triangle has to contain a total of 180 degrees. Go ahead, Randall. Continue.
And we already know two of the angles in one. And if they're the exact same, the rest of it has to be the rest of the other 180 degrees.
So this plus this has to be 180. This plus this has to be, well, if this is the same, and this is the same, you have to add the same amount to get to that 180. So boom, right away you know that that equals that, which makes those triangles similar. As a matter of fact, there's a postulate in geometry called the angle-angle postulate that says, this is actually kind of cool, it says if you can prove that two angles of one triangle equal two angles of the other, they automatically have to be similar. Which means you don't have to bother checking the third one, because the third one's given. It's forced to be equal. If the first two are equal to the other two, the third ones have to be equal, because they have to add up to 180. It basically numerically has to be. If you don't believe it, throw some numbers in it to check it. These have to be 90. What do these look like-ish? 50? Call them 50. If that's 50, that's 50. If that's 90, that's 90. So 50 plus 90 is 140. 50 plus 90 is 140. The leftover's got to be 40 on both of them. Fair enough? Good. So now we know those two are similar. We know those two are similar. The question is, why do we care? Because now we know they're similar. Exactly. We're like, okay, okay, great, because you wrote on the board in the marker. Good. Why do we care if they're similar or not? This is a very, very good question. Tell me your name. I'm trying to guess, John. Will, go ahead, my friend.